Good evening, everyone. So, as we proceed in our journey of World Space Week event from 4th October to today's 9th October, okay, we have our one of the special keynote speaker, Syed Abuzaid, okay, who is currently integration test engineer at Skyline Drone Tech Private Limited, and previously he has worked as a UAV engineer at Bot Lab Dynamics, and before that he possesses great entrepreneurship too. As the theme for this particular World Space Week is space and entrepreneurship, so he is the mixture of that particular thing, that he also has knowledge of space and he also has the knowledge of entrepreneurship. So he has built a team of around 75 people. So yeah, it means he is a good team player as well as a leader. Okay, so today he will be guiding you onto the journey of rockets, propulsion systems, and the basic fundamental of rockets. Okay, and furthermore, guys can ask any of the questions regarding entrepreneurship or rockets. Okay, so over to you, Sayed, and all the best for the session, everyone.
Okay, sure. Thank you. Thank you so much, and thank you so much, you all, joining this evening with me. So today we are going to know and understand about the basics of rocket and behind the technology of the rocketry, history, and the modern technology of the rocketry and the modern rocket history, and there are the parts, some components. In generally, we will just know about the basics. I'm not going in depth because we have only 1.5 hours. So so in this session, we having 15 minute or 20 minute for the doubt session, and some quiz question is also there. So you can ask anything, whatever question you have, so you can ask me, and I'm trying to give my best. So let's start. So history of the rockets. So in first true rockets means the peoples which think about the missions using of rocketry in the field of space, in the field of battles. So so their first true rockets were built by accidentally, like some people are doing with powder to making some explosive. So they have seen one of the explosive will burn and it travel from point A to point B. So they are trying to think what it is happened and how it is happened. So in the first century, basically Chinese are repeatedly had simple form of gunpowder made from the sulfur and this mix of the charcoal. Basically, that's soft charcoal coming up from the wood, like coming from the tree, burn of the wood. Then we can say soft charcoal, because we can define there's a many types of charcoal nowadays. You can go in there's the natural charcoal also present there, so we cannot go through it. Just we can say the soft charcoal that comes from the wood. So sulfur is also one of the chemical we are using in gunpowder, and there is a potassium nitrate. Some of the nitrates also present there. Most of the oxidizer also present there. So we'll talk about it in next tab. So basically, how their Chinese are using this the rocket. So they filled inside the bombo tubes with the mixed and tossed into fire. So they just fire. It will travel only like a 50 to 100 and 1,000 feet only. So it is the beginning of rocketry. So and it was a fully, you can say, it is a not liquid propulsion system. It was a just solid propulsion system. So they're using the solid fuel. You can also say the grain. Solid fuel nowadays we are calling it grain. Okay. So the date reporting the first use of the true rocket was in 1232 century. At this time, the Chinese and the Mongols were at war with each other. So during this battle, the Kai King, there was the battle is a place where the name is Kai King. The Chinese repelled the Mongoloid invaders by the barrage. barrage of the arrows, the flying fire. Basically, they are making a small rocket with the help of bamboo tree piece, making with there is a tube they filled inside the gunpowder, and in front of the warhead they just making the metal arrows so that it will travel like nowadays. Now the people are using the arrow just with the help of threads and the rubber tubes. So they are using a small piece of rocketry. So it provides the a maximum thrust, and that goes in comparison to rubber tubes and the thread. It travel much more, like a range of approx 1,000 feet. On the time, 1,000 feet of like a range is very big. That's why the first use of the, you can say, small missile in at the time of 12th century, they have made by the Chinese against the Mongols. Okay. And if I'm going to talking about the modern rocketry, so in Russian there is school teacher whose name is Konstantin Solisky. He is born in 57 to 1935, and he died in 1935. So he proposed an idea of space exploration by the rocket. So the on this time, people are just watching the space moons, and they are just trying to find the solution to how can we travel in the space, how can we understand, how can we go through it. So, and they are just trying to do is measuring the speed of light. It's all the part of imagination. So on this time, Solar Sky suggests that the use of liquid propellants of the rockets. So the, in the beginning time, the use liquid propulsion system cannot provide the on those time cannot provide the enough thrust to the takeoff from the ground and travel to the that exceed the thrust to that exceed the maximum thrust, so we can take off from the ground. So on those time, the liquid propulsion system is the very new technology that is just in a paper, like a theory paper. So that's the time the modern Russian teacher, and that's I have already told you his name is Suluskay. So who proposed this theory, and we also know that his nowadays he is the father of modern aeronautics. So the basic principle of the rocketry is every actions give equal and opposite reaction. So you can already see, you can already feel, you can already mainly you can already feel while the accidentally you have put through a balloon. So you have seen the balloon. There is a mass inside the balloon, air mass. Okay. So when we throw it, it will automatically pull up, like it flow the maximum air through its throat, so that we can also say that nozzle, yani above part of the rubber. So the balloons above, so the hollow part of the balloon, hollow nahi, we can't say. So the balloons travel from the point A to point B. So the people think that how it is travel. So the basically on those time nobody knows. So nowadays, and nowadays in the time of modern technology, people understand that this is the basic principle of the Newton. So the rocket, so they have defined in the simplest form. Rocket is the simplest form of enclosed gas under the pressure. So the small opening at one end of the camber allows to the gas to escape. So in doing so, provide a thrust that propels a rocket to opposite direction. So you can see here in the diagram, above the nose cone of the rocketry, and the top of the part is called nose cone of the rocketry, and the bottom line, that is also called nozzle, throat of the nozzle, and there is a some parts. The first number that comes in the top part is there is a nose cone inside. We have nowadays we are putting the warhead, we are putting satellites, anything that is a payload site on the thereafter we have seen there is a some propulsion system. There is a some like a deployment function system like a parachute. The mechanism are set up under that. Then after there is a then after on those space we are using for the grain, we are using for the propulsion system. So there is a and they all are space are using for the engine setup. And then after there is a space for set up the fins of the rocketry, that provides the stability to the rocketry. And then after the nozzle. So there is a different types of rocketry nowadays. They are with fin, they are without fin. So there is another nowadays the rocket which fly through the electronics, like with the help of gyroscope. They don't need the fins on the at the time of beginning of the rocket. People are using fins because the fins provide the stability to the rocket to travel in a straight path. So I'm talking about the Newton's law of motion. So there is a three. We already know that there is a three law of Newton's. First one, which is the object at rest will stay at rest, and the object in motion will stay in motion in the straight line unless action upon by unbalanced one. That means you cannot disturb anything which is in rest. It is always remain in rest. So unless we can disturb it, unless we can pull it. The second theory of the Newton's force is equal to the mass time acceleration. That means if I provide some force to the some object which value is x, okay, then I have to apply the force with the value of x. That means the force and the object, both of the mass and the force, both have to be equal. And for the last one, for every action there is always equal and opposite reaction. So we cannot feel it in earth. You can feel on the space the third law of motion. But nowadays the efficiency of the third law of Newton's third law, nowadays you can feel 40% to 70% on the earth ground. And this is the practical rocketry nowadays. These are both of the technology. First one is the liquid propulsion system, and the second one is the solid propellant rocket, and basically solid fuel powered rocket. So the first one, there is a two types. There is a different type of fuel that is called liquid propellant. Another one is the solid fuel. There is another type of fuel that is in the form of solid. So basically, these all are the categorized. So nowadays, in liquid propulsion, they are using uh, they are using like hydrogen, oxygen. They both are mixed together in the presence of like of oxidizer oxygen. So then after when we have ignite, it expand and it comes out through the nozzle with the in the combustion chamber. They have make very large number of pressure. So the pressure in the Bernoulli, if you have knew the Bernoulli theory. So the pressure, if the we will increase the pressure, then after the nozzle, the velocity will increase. So the it is the just opposite reaction. Pressure will increase, then the velocity will increase. If the velocity will increase, then the pressure will be decreased. Okay, just like I am telling you in a simple form. So the most rocketry today operate with the either solid or liquid propellants. So basically nowadays solid propellants are used in first stage of the rocketry and in the missile nowadays. But in the liquid and most advanced rocketry, they're using liquid propellant rockets also from the first stage to the last stage of rocketry. Okay, so basically the cryo engine used in the for the liquid propellant rocket. There's many another engine also, but the popular engine is the cryogenic engine for the liquid propulsion system. One of the another engine nowadays made by one of the England startups. They are using um, electronics like a electric power propellant system that increase the pressure. There is a nowadays in cryogenic there is a one of the important mechanism is compression. So which compress the oxidizer and fuel together that mixed. Then after there that flow inside the combustion chamber. So this process is the very important process in the cryogenic engine. But I'm talking about the England, that is a startup who made the simple and very small fuel and oxidizer mixer that produces very high level of pressure inside the combustion chamber. So the basically two mass are there inside the fuel. First one is oxidizer and another one is the fuel. So the fuel have the carbon atoms, and in oxidizer, which oxidize, this is the oxygen. In the without oxygen, we cannot burn anything. So the in the presence of oxygen, we can we can we can ignite the fuel. So the presence of oxygen, a fuel will ignite, burn, and which produces a large number of molecules. We can say mass. So the mass come out through the throat of the nozzle, and that makes the equal pressure, equal thrust to the mass of the rocketry. That's why the rocketry pulls up from the ground. So there is a basic principle of Newton. Third law: every action gives equal and opposite reaction. So the mass have to be come out from the nozzle, equal mass to the rocketry mass. So the fuel is the chemical of the rocket burns, but the for burning takes place and oxidizer oxygen must be present. I've already told you. And the another part, what happened? So now we have some question I have. So I'll ask to all of you, the guys, if you can. One sec. Hmm. So I have some question. If you know, please give me answer. And if you don't know, also please give me the answer. I will see. And if you want, if you hesitate to give the answer directly through the your mic, so you can also type in your chat box. So basically, one is rockets are able to lift off and travel because of. There's a four option. First one is thrust. Second one is speed. Third one is velocity, and fourth one is escape velocity. So if you know, please give me the answer.
Uh,
Thrust. And anyone else, please. Anyone else, please.
thrust.
So okay, so thrust is the right answer because the rocket in the fuel and oxidizer are burned inside the combustion chamber. That increases the pressure, and that pressure produces a thrust. That's why rocket are able to lift off and travel. And the second question is related to Newton's third law, action and reaction theory. What is the reaction when the rocket expels gas, smoke, and flames from the nozzle end of the rocket engine? So first one is nothing. Second option is propel in the opposite direction. Third one create balance force, and fourth one is the create friction. I am asking once again, related to Newton's third law, action and reaction. What is the reaction when a rocket expels gas, smoke, flames from the nozzle, and we can say the end of the rocket engine? So the end of the rocket part of the rocket engine is called nozzle. So what the rocket expel, and what happened the rocket when expel the gas smoke according to the Newton third law? So
Like
what is the right answer?
propulsion in opposite
Propels in
direction.
the opposite direction.
Okay, propel in the opposite direction.
Yes.
Okay, your answer is propel the opposite direction. Anyone else? So the opposite direction is the right answer. So on the opposite direction, that is the that provides the equal and opposite reaction, because if it is not happened in the opposite direction, then the vector is equal. So the meant is the zero vector. Okay. So that is the there is a no any kind of thrust. There is a no kind of movement you will see. So the opposite direction thrust is must to have experienced the Newton's third law. And the fourth question is, why do rocket use oxidizers?
Rockets use oxidizers because there is no oxidizer in space, or we can say there is no oxygen available in space in vacuum.
I'm repeating the option. They are needed to create oxygen for the astronauts. They allow to rocket to operate in space. For third one is oxidizers keep Earth bacteria from the contaminating space. For one is Earth oxidizers keep potential aligned microbes contaminating the Earth. Which one is the
Sec-
right answer?
Second,
Second is the right answer, because I'm repeating one more term here. There's a two type of engine. Okay, one is breathing engine and another is a non-breathing engine. So the aircraft and all the flying which is under the atmosphere, that is called air breathing engine. Okay, you can include your motorcycle also. And those who are flying above the space, above our atmosphere, that is called non-breathing engine. So anything we have to like burn, we need oxygen. So without oxygen we cannot burn, we cannot do anything. So the in the presence of oxygen, we can burn anything. So the right answer is two. They allow to rocket to operate in space, because in space there is no oxygen. So the oxidizer, main use of oxidizer in a space to burn the fuel. That's why the oxidizer used in the space, because rockets, space rockets are non-breathing engine. Okay, and the fifth question is, what is the main difference between a jet engine and the rocket engine? So uh,
jet engine
already.
uses air for the supply of
So
oxygen.
the option is rocket engine function by expelling hot gases operate to the direction of desired acceleration. Jet engines do not. Second option is jet engine having nozzles and rockets and do not. Okay, rockets do not. Jet engines having nozzles. Rocket do not. Third is jet engines get oxygen to burn fuel from their air, and rocket engines carry their own, which allows them to operate in space. And the fourth option is jet engines are generally more powerful and wasteful than rocket engines. So which one is the right answer?
Third,
Third.
one.
True. True, true. Third one is the right answer, because the engine is the air breathing engine. They are flying inside the atmosphere. So they are just taking the oxygen. There is a some bypass ratio of the jet engine. Like nowadays, the 50 is to 1. One molecule of fuel and 50 molecule of oxygen they are using. So that they are using the oxygen from the atmosphere. And in rocket, they are carrying its own oxygen. There's oxygen tank inside the rocket payload, inside the rocket. So they just kept the oxygen mixed together with the fuel and then burnt inside the combustion chamber. So after the burning, that create the pressure, transfer convert through the nozzle, it in high velocity, and that high velocity which provide the thrust. That's why the rocket remove. Huh. And this is a very important question for you all. So I just want to know what's your opinion, and please give me the answer for the. I expect from the maximum people. What are the difference between a solid fuel rocket and what are the difference between liquid fuel rocket?
The solid fuel rocket uses the components which are inside the propellant are in solid form. In liquid fuel means propellant or rockets, they have their propellants or the parts of propellants in liquid form.
Okay, liquid form. Uh,
Difference in
you are
states.
going, yeah, correct, correct, correct. So the basically solid fuel rockets are in the form of solid. They're the both oxidizer and the fuel are also there. I mean, if I'm talking about the liquid fuel rockets, so there is oxygen in the form of liquid. There is a hydrogen in the form of liquid. So there is a two nowadays we have two types of fuel: oxygen fuel, solid fuel, and liquid fuel. So uh, you have said right answer. So we will proceed for the next step. And another question is what is the purpose of fins on the rocket? What is the purpose of fins on the rocket?
Stability, sir.
Yeah, stability.
Uh, stability is
Stability, sir.
stability is the right answer. Basically, fins
And
produce. There is a four force acting on a aircraft. Okay, basically thrust. There is the opposite of the thrust is drag, and lift. Opposite of the lift is what? Opposite of the lift is gravity. So the basically four forces acting. So basically fins are creating a drag. Due to drag, it provide the stability direction to the rockets. So the basically you have seen in aircraft there is vertical stabilizer, horizontal stabilizer. There is a many control six control system in aircraft. But if I'm talking about the rocket having the fins, that is the control system of the rocket which provide the direction, stability to the to while the traveling the rocket. Okay, so some basic, if I'm going to talking about the some basic parts of the rocketry in with the some example and some basic theories that have been written in this PPT. So the first one I have categorized is all. So the first one is nose cone, that is the top part of the rocket. We say it nose cone, and whether we will carry some payload, some warheads inside it only. Okay. Then after the space, the second is space where the parachute lines, like in the parachute, if you are making some scale size of rocket, so we are carrying thread. Okay, thread of the parachute. So there the function parachute deployment function. So there is a two method like electronics method, so through the servo, and the another method they are coming from the some explosive from the combustion chamber, that when the combustion chamber is in the position of yield, that explode the combustion chamber, and that provide the deployment function of the parachute. That is the another stage. Then after shock code, I have already told you that is called shock code, basically which provide the uh, explosive force, which provide the force that helps to deploy the parachute. So, lynch lug, parachute, recovery wedding, and this all the parts are in the third category, third stage of the rocket. Okay, present in the third stage of the rocket. And what about the fourth stage? The fourth stage also present their payload. So the basically above the nose cone, like if I'm talking about the nose cone, so if you can see the cursor, so basically this is the nose cone. From this to this line, these all are the space of payload where we kept the parachute mechanism, where we kept the some warheads, where we kept the satellite. Every payload function is only present here. Then after engine. So whether you are setting up the liquid propellant propulsion engine where you kept the solid propulsion engine, so that they are then after the all space are using for the engines. Then after fins, so above the space, the body of the rocketry, we set up the fins. So basically, four fins are good for making a rocket that provide the enough stability to travel anywhere, and that provides a very good aerodynamic stability, so rocket can travel very straightly and very controlled. Then after, the guided system are also there. So I will definitely talk about the guided system, how it's functioning, and how nowadays rocket fly without fins, and how it's find the direction, and what kind of technology rocket are used nowadays to the travel from point A to point B. Okay. Then after the space, the place is for the nozzle and the ignition system. So the ignition system is nothing. There are two and three type of ignition system: chemical ignition system, electrical ignition system, and some another ignition system is by the hot rod. Okay, so basically chemical ignition system is just like a grenade. There is a some pure acid like sulfuric acid inside it, which that when it is touched to the gunpowder, it automatically reacts and burn out. Okay, that is the chemical ignition system. What are the electrical ignition system? So the basically they are using the coil, basically some high resistive material like a tungsten they are using for, and they're just passing the amount of current so that it is heat up and burn out. So throughout the propulsion system is start. I'm talking about only solid fuel rocket. Okay, noted. And there is another system. So another system are the hot rods. If I'm talking about the similar like a spark plug, they are just passing the some amount of current through it. This is the function of the cryogenic engine. Okay, so say for the small amount of liquid engine, first initially burn out, then after the nozzle in the liquid propulsion system, the basic the working of the nozzle, both there is a some space ring shape solenoid shape, like a pipe which is covered above the rocket, which which basically sink the temperature, heat temperature of the nozzle, because the while flying the rocketry it cross the 25 degrees Celsius of temperature on the nozzle. So the how we can cool the nozzle, so that through the pipeline, through the solenoidal shape of the fuel solenoidal shape of the fuel pipe. So when the fuel passes through it, so which absorb the temperature and which go inside the combustion chamber. That means if you have been seen the stove at your home from the like 10 to 5 years ago, we are using in our home a small kerosene fuel we are using in the stove. So we are just passing some amounts of pressure, so the pressurized fuel is coming from the nozzle. There is a small piece of nozzle, so that when we burnt out the nozzle, so that it is continuously start, because the nozzle which provide the flame, and flame also heat up the solenoidal rings, and solenoidal rings which heat up the fuel, and fuels are convert in vapor. So in the form of vapor, the oxygen and the fuel which is mixing together very with a very good bond. That's why in this form we can burn any kind of fuel very easily. If you have seen in your kitchen, while our mom and while our mom and we also trying to fry something above the stove, when the oil is very heat up and it is turned into a vapor, you can see the suddenly it it suddenly it comes with a blast, like it burn out, like a small explosive. So how when the any carbon material, any kind of fuel, which is turned into a vapor and which mix together with oxygen, so it is very highly explosive. So this is the basic mechanism and the basic principle of the cryogenic engine. So the in this mechanism nowadays the cryogenic engine or modern technology are also working on. Okay, so the this is the parachute lines. There is a number of nodes you have seen here. So basically, this parachute lines, there is a should be these lines you can say threads which connect to the parachute canopy. Canopy, there is a top notch part of the parachute, which like a outer side part of the looking like umbrella, which one of the corner where these threads are tied and bind together so that there is a sum of number of five, sum of number of eight, sum of number of six they are using for making the parachute, which depends upon the mass of the rocketry and mass of the payload. So you can calculate it like if your mass weight is 30 and what is your descent velocity. Descent velocity means the velocity which passes through the air resistance. Okay, like a parachute which comes down and which resists to the air resistance. So that velocity is called the descent velocity. Okay, so the parachutes are made of strong threads such as carpet thread, but they also may made be another material like carbon fiber, like a glass fiber material. Also, they are using because they are the modern material nowadays. Carbon fiber and glass fibers are. So the number of shroud lifts varies. I have already told you like a six, eight depends upon the stability, depends upon the needs. So they are using. And if I'm talking about the parachutes, the all the modern there's a different type of parachute. Okay, so the if you have seen the ring shape parachute, so the basically they are using for the deployment only because the ring shape parachute which comes from the which coming down on a straight path, and you have seen another type of parachute that are used by army and some like athlete also because there's also another sports. So there is another type of parachute which nowadays they are using for flying from one place to another place. But in rocketry, they are only using ring shape of parachute for the deploying something because it's come down on a straight path and with some like highly efficient velocity. Like if I'm giving calculate its descent velocity will be 25 kilometer, then its descent velocity will be 25 only. It cannot increase. Depends upon the air direction, like air current cannot affect it. Okay, because there was another aerodynamic like cutting path, cutting edge is also inside that. If you have seen the real parachute and you can see in the YouTube, there is some ring shape cutting above the parachute you have seen, so that they are allowed to pass the air and which provide the stability to the parachute. Because if we cannot cut above the parachute, so there may be some accident. They will turn, they will move anywhere. So that we have make some like a cutting edge on the top notch canopy of the parachute that provides and that allow the air inside it, so it provide the straight path, just like a fin. Fin is outer part, but if you can make a small hole, like if you breathe some air, so it provides the only straight path of direction. Okay, so I'm just explaining with a little bit of that I have written inside this. So all the model rockets required a recovery system to slow their descent and return them safely to the ground. The most common type of recovery system is the parachute. And there's another type of technology nowadays is coming up. There is a maple seed functioning. Have you seen? There is a small fruit, or you can say flower, and many of the leaves are also coming down from the trees while moving in a circular path. So that is there is a seed that is called maple seed. So the maple seed theory coming comes from the seed that is coming down while the moving while it's spinning and coming down to the ground with a some decent velocity. So these are the technology nowadays we are working on it because they have highly efficient in comparison to parachute. Okay, that doesn't affect of any air current on it. That's why the parachute may be made from the thin plastic or clothes. We have already experienced and we know that the material of parachute. So basically, they're using the nylon material on parachute, and that is a plastic also. And if they are talking about the cloth, that's not a cloth. That is also only the parts of plastic, nylon, some and another like ABS material also there. So the parachute is expelled from the body tube by the ejection of charge, rocket, motor after. So basically, I have already told you, rocket are ejected by like a deployment function of the rocketry. Rocketry how it works. Some of they are using servos, electronic system for the ejection. They are using little explosive there when the propulsion system is at the position of field, then it will automatically the eject the parachute from the rocket. So there is another different types of functioning nowadays, and I'll tell you the modern function we are using nowadays for the deployment or ejection of the parachute. So after some tabs, I'll tell you how can you make it and what are the components and what are the types of ICs and chips we are using for that. Okay, so basically, I'm just trying to explain the recovery wedding and how the recovery function are working in the rocketry. So this is the basically scale model which they are using in some small competition in our universities or college. I'm telling you how can we make a small rocket at your university, at your lab, or at your college, but don't use it and don't try to make inside your home because it's a highly explosive. It's a definitely it will be dangerous for all of us. So I'll tell you what kind of precautions we have to need. Then we can make it. Anyone can make a rocket at home. Okay. So basically, this is the recovery mechanism in rocketry, how recovery mechanism works inside a scale rocket. Okay, scale rockets, you can say sugar rocket powered. This is a multiple names for this kind of rocket. So basically, this is working on solid propulsion system, and solid propulsion system is a very short range mechanism, very short range engine. That's why in missiles and at the first stage they are using, but if I'm talking about the mm, thrust, they provide very high amount of thrust. That's why we are using at the first stage of solid propulsion system. If you knew about the mechanism of bike, you have experienced that in first gear they have high power. There's a many power, okay, but it cannot provide the speed. It provides a limited speed, but you will feel the enough power. So that is the same in first stage. They are using solid propulsion system because the solid propulsion system which provide very high amount of thrust, but that cannot provide the enough velocity because the size of mass inside the solid fuel is very big. So the big amount of mass, big amount of molecule that provide the enough thrust only that produce enough force, but the flow velocity, the mass flow velocity is less as compared to the liquid propulsion system. So in first stage, they are using solid fuel rocket. That's why in missile, we just need the initial thrust for in battlefield. That's why they are using solid propulsion system. But in some of case, they are using hybrid rocketry also. In first stage, they are using solid propulsion system. Then after they have opened the above vent. Okay, they are using scramjet mechanism like they are using air breathe technology. Air is coming from the atmosphere. I'm talking about the missile. Okay, air coming from the atmosphere in that means which provide the oxygen. If you have maximum number of oxygen, then the explosive will react with the maximum number of like a shock that provide maximum number of shock. Okay, so that's why the hybrid rocketry mechanism is nowadays working in missiles. Okay, so I'm talking about recovery wedding. So recovery wedding is flame resistant material. So the recovering wedding is a flame resistant because the end of the part is propulsion system is there. There is a high temperature coming out, so we must need to cover it by some material which cannot allow to the pass the temperature or heat, high temperature or heat. So they're using the kind of material which resists the flame. So the material is sometime your wood can be, you can use wood, you can use plastic material, any kind of non-metals that cannot pass the heat, we can use it. But in rocketry, we have to understand a value of gram of weight because the gram of weight is matters while making rocketry or aircraft. So that's why they are using advanced material such as like a carbon fiber, PVC, like a carbon fiber and the PVC, the maximum melting point of the carbon fiber or PVC is 25 degrees is compared to the steel. Okay, and the material of the nozzle nowadays we are using is graphite because the graphite is graphite can resist very high temperature above the 32 degrees of Celsius. So they are using graphite at the in the place of nozzle, and some of they are using the polished the graphite material. Okay, so the mechanism which is present inside this tab is the hot blast motor ejection chart. So the basically they are using some small piece, and when the combustion chamber or the when the combustion chamber or the combustion of the solid propulsion system at the end point, then they just pass a small piece of spark to the explosive material, and the explosive material that creates enough explosive that could be the recovery or the like a parachute will come out from the rocket. So that this is the very easy way to the deploy the rocketry while it is in the atmosphere. Okay, so if I'm talking about the payload, so not all rockets having the payload section. The model shown as clear plastic payload section that allows any payload inside the easily inspected visually. So the previous I've already told you in different type of rockets nowadays. So they have different motive. So in this place, some of the rockets which are using payloads like a satellite. Some of are using payloads like a bomb, some explosive material. Some they're just trying to they're trying to do some research. They are using some research material, and also they are using for the safety, like parachute deployment function is also present there. So depends upon our motive. So the payload section is always from the nose point to the till to the above the rocketry propulsion system. So this space are using for the payloads. Okay, and I'm going talking about the engine. So now I'm just going through the solid propulsion system. it works and how can we make and what are the type of um solid grain shape that provides the different types of thrust at the different stages. Okay, so the some basic uh, mm, form of the solid grain. Solid grains means solid fuel. Okay, so some basic form like there is structure are different. If I'm talking about the plain sheet of paper, so you can easily burn the plain sheet of paper because the air is easily mixed together and burn out. But if I'm talking about if you will try to burn some circular part of paper piece or anything, so it cannot burn easily. And if it is burned, so then it will very slowly burn out. So it depends upon the size and shape of the grain. That's why the some type of shape and size inside the solid propulsion system. So one thing I haven't if I'm talking about the liquid propulsion system, so that we can say liquid propulsion system is a control propulsion system. We can control. There is a controller inside the oxidizer, so we just pass the enough oxidizer, enough oxygen, so that allows to the control burnout. Okay, but if I'm talking about the solid propulsion system, that is uncontrolled propulsion system. We cannot stop once it is ignited. Okay, so the engine or motor, the model rocket is commercially manufactured solid propelled rocket motor that is good for one flight. I have already told you for the first stage that is a very good because that produce very high number of thrust. Model rocket and the motors are typically motors, that means the shape and the engine of the solid rocketry, that is also called the rocket motors. Okay, so the rocket motors are typically made from the thick wound paper tube. So this is I'm just trying to speak about the scale rocket. So they are just going through the paper tubes because the paper is a insulator that cannot pass the heat from above layer of the rocketry. Okay, so the motor contains a ceramic nozzle. So there some of they are using cement, some of they are using like a small amount of mud for making the rocketry nozzle because they all and some of the ceramic powder, you know, as some of many people are using like there is a white powder, what it say, I forget the name actually. So the people which are trying to make a small size of rocket, so they are trying to make the nozzle which resist a very high temperature. So people are using some of the cement, another material, some of the using metals also. So in a scale rocket, we can use it. Okay. So what the things are we can use in a small size of rocketry. So there is a different type of fuel. So I can give you one of the ratio. So we can get 40% of the fuel, like fuel in you can if in the place of fuel you can take soft wood, charcoal, you can take sugar powder, and you can take some high carbon materials. Okay, like a binder is you can see the rubber material, the powder of rubber, also using in space rocketry because that have maximum number of carbon atoms. So the maximum number of carbon atoms, we can say that is the very good fuel. Okay, so the we can take sugar as a fuel, and in the place of oxidizer for 60% of oxidizer, but we just need to take like 55% of oxidizer. Okay, the 55% of oxidizer is potassium nitrate, any nitrates you can say. 1% of you can take iron oxide. Why iron oxide? Because the iron oxide conduct the temperature from point A to point B. Okay, this is the metal powder, so that carry the temperature. So that provides the temperature to the mixed with what oxidizer and the fuel. So we have to use 1% of ferric oxide and the 2% or 3% of sulfur. Why sulfur? Sulfur is the highly explosive material. If we are using inside the fuel sulfur, that helps to that helps to conduct the flame of the rocketry very fastly. But if we want to use controlled burning, so some of people are, and there's a theory we are using paraffin also. So if we are using paraffin moom inside the fuel, that helps to burn in a control system. It cannot burn directly all the fuel, so it's burned from point A to point B. So I'm also talking about the shape of the fuel, shape of the grain, so that will provide the different type of thrust at the different stages. Okay, so I will tell you in next tab with the shape of the grain. So I have, so let's we know about the guided system, then I'll tell you about that. So the guided system of the rocket is responsible to the controlling the rockets in the trajectory and the ensuring that the reach in intended destination. So the guided system, we just give inside the guided system some latitude and longitudinal number. Like if we have nowadays in our smartphone, we are using GPS. Okay, so GPS is working like a eyes, working like a brain. Sorry, GPS is a working like a brain. GPS knew that direction. GPS know the exact places, exact position. But in the place of eye, we are using magnetometer, compass. Okay, there is an electronic chip. Nowadays, we are using compass, magnetometer. So the magnetometer which follow the north direction. Okay, so we have one fixed direction. So we can now we can if I know any one direction, so I can easily find the another three direction also. So that's the basically that's the basically function of the magnetometer, which provide and which working like a eye inside any kind of flying ships. Like in if I'm talking about the rocketry, so the magnetometer is the responsible which provide the direction to the rocket, and the GPS which give the path give the path to the rocketry, so the magnetometer follow the path. So I will show the flight controllers. Okay, the flight controllers nowadays which we are using inside drone, inside aircraft, anything. So the flight controller is responsible for the guided system. Okay, you can use your drone flight controllers also in rocketry, so that flight controller allow you provide you the exact trajectory, location, exact am to your rocketry to travel from point A to point B. The guidance system uses various sensors. So the sensor are basically accelerometer, gyrometer, barometer, and GPS. So these are the sensors they are using they are in inside the flight controllers. So that provide the some data. So that's why guided system of the rocketry are functioning. Okay, so these are the main component working in the guided system of the rocketry. Magnetometer is working like eye, GPS, brain. You can say that provides the direct a location to the rocketry. Radio RxTX means one is transmitting device, another is the receiving device. Okay, so if you guys are working RC drone technology in drone. So you have been seen, and if you are using mobile phone, so you have seen one person is listening your voice and one person is speaking. So the transmitting device is in ground, okay, and receiving device is inside the rocket. So once we are provided the exact location to the rocketry, so the that are taking control from the base station, that is the transmitting station, that is the transmitter, and the one who's receiving the signal from the ground station, that is the receiver. Okay, so the radio RHTX is also working there. So basically, this is the magnetometer. So magnetometer is the electronic compass can similarly help to indicate the direction is the magnetic north using phenomena such as Hall effect. Okay, so the basically the Hall effect is responsible for making the electronic magnetometer. Okay, so Hall effect, how it is working, you can see in YouTube or Google. There's the information about it. So I'm just telling you. Basically, there is a four direction small electronics threads are there, and in the center there is a small piece of magnet. So once the magnet is influenced from the some direction, like basically from the north, so the those direction there is a opposite direction coil will read this magnet is influenced by this direction. So in this way, magnetometer can understand this IC can easily understand. So I have to follow this direction, and this is my right direction. So this is the basic principle inside the chip in the magnetometer. This is the GPS. Basically, this is a patch antenna GPS. Okay. So GPS, the global positioning system, the full form of the GPS is a network of satellites. Basically, GPS is connected directly to your satellite. Okay. That is the receiver RX device. Okay. Used to determine the location something on Earth. Basically, one of our TX device is above from the ground. That is satellite. Satellite know the every position on the ground, every laterals. So if I am giving the sum of the lateral position of the ground, so the satellite can see this position. Satellite have the information about it. So the satellite give the transmit the data of exact pinpoint location. So the GPS give the information to the magnetometer and gyroscope and accelerometer. So in the combination of this all data, which is working inside the IMU, okay, inertia measurement unit, IMU. So basically, IMU is responsible for the guided technology. So basically, this is the flight controller you have seen. There is a small piece of microcontroller. Nowadays, we are using STM32. So you can get from it, you can buy it in from the Google, and you can use in your drone. You can use in your small size of rocketry for the guided system. And in there's the application called Mission Planner, which provides the some of the option for your scale rocketry and deployment function also. So if you are using flight controller, so your rocketry is working very simply. Your deployment function will be very simple. Parachute deployment function will be very simple because it's calculate the altitude. It can easily calculate the velocity. It can easily calculate your direction, motion, movement, everything. Okay, so the flight controller, there is a multiple of sensor, and it is not very expensive. It comes nowadays. We can buy it in 3 to 5 or 10,000. Okay, so we can make through it, and the rocketry are made up very advanced. That's why nowadays most of wars they are using drones, because the drones is very cheapest technology nowadays. So I'm coming back about the solid fuel rocket. Okay, I'm just telling you the functioning, the things, how can we make, and I'll give you some example I have did before also in my college time. Okay, so the nozzle is a critical component of the rockets. Basically, it is the main part of the rocketry which is responsible for the producing thrust. So the nozzle is a critical component of rocket propulsion system. It is the final part of the engine through which is the high pressure, high temperature exhaust gases produced by the combustion of the rocket propellants and expelled very high velocity to produce thrust. So basically, it is working on it both in solid rocket and liquid rocket, liquid fuel powered rocket also. So that there is a different types of nozzle. One is you can call like divergent nozzle. Another is a convergent divergent nozzle. So in the liquid propulsion system, and they're using convergent divergent nozzle because if you want to fly your rocket beyond the speed of sound, we need to use like a hypersonic speed, supersonic speed. We need to use CD nozzle, convergent divergent nozzle. Okay, so the convergent divergent rocket, which helps to supersonic that produces a shockwave, and shockwave is very dangerous. If you will listen nearby the object, so my ear, the blood is coming out from our ears. Glass will be broken also. So be serious. If you want to make it, so don't make inside your home. Please use in your college laboratory with the all precautions. So I'll give you the data of precautions, what kind of things you can use. So if you knew the designing tools like CATIA, SolidWorks, anything, so you can design your rocket bodies inside it, and you can print throughout the 3D printer also. So I have very less time mm, for this session. So I'll just tell you about it if I having, so I can show you how can we design also. So this is the another topic for the designing. So I'm not here for that only. So I am just telling you we can design our own body. What I think, what kind of idea we can use inside it. So can nowadays we have 3D printer. We can print throughout it. We can just design anything and we can print out. So we can use 3D printer for the making the rocketry, and above the 3D printer material we can covered by the some ceramic material also. So it reduce which helps to resist from system. So the basically this is the ignition system that I'm showing here. So the above the top notch of the ignition system, there is some like gunpowder material here, or you can say explosive material here, and the material both of the direction is the conductor. Some of are using a tungsten wire also, but this is the best thing. Okay, so when we are passing the electric current throughout it, it just ignite, and ignite after the ignition, it helps to burn the or initiate the solid propulsion system. Electrical igniter, pyrotechnic igniters that I have already told you. Okay, spark igniter, that is called pyrotechnic igniters, also called as spark igniter. There's a ejector. Okay, nowadays in aircraft, they are just burning. They are just producing a small this, flame. So those kind of igniter we are using in liquid propulsion systems also. So depending upon the specific design of the rocket engine, when the ignition source is activated, it ignites and fuel and oxidizer mixed combustion chamber, initiating the control exposition, produce high speed of exhaust gases that propel the rocketry. So the basically this is the mechanism, very simple, very cheap mechanism we can use for the ignition of the, and which is a control also. It is a control burning also, and we can make some switches knobs also for the ignition from the very far distance. Okay, so we cannot go directly to the igniting the rocketry. So this is the best way for the ignition the small size of a small piece of rocketry. So I'm coming about the practical rockets components we are using now. We are using. Okay. So I have some question for you guys. What is center of pressure and what is center of gravity? If you know, please tell me.
So, center of gravity is a point in body which can be said the mass is accumulated at, and the center of pressure is like the point where all the aerodynamic forces balance in front of it and backwards.
Correct, very good. Basically, center of gravity, the whole mass of the body is concentrated in some specific point is called center of gravity. Okay, and the center of pressure, where the pitching moment is in independent. Like if I'm talking about the aircraft, so the pitching moment here, nose can go up, your nose can go down. So that those point which cannot, which is fixed point. Okay, that is center of pressure. So then after the point that can move, and before the point that can move, but the point where the which provide the freedom to the pitching movement, that is called center of pressure. So basically, we can see in rocketry, center of pressure is the nearby your nozzle. So the center of pressure where the pitching moment is allowed for the movement. So the center of pressure cannot move any direction, which allows and which is the centric point where where the control system is functioning. Okay. So here I have already mentioned what is center of pressure and center of gravity of rocket. So the you have seen in aircraft the center of gravity is in center, the center of pressure is in center of the aircraft. Okay, it is lie one third of the wing area. Okay, one third points of the wing area. But in term of rocketry, the center of pressure is nearby the um, nozzle. Why it is, we will see. We will see in our next step. Okay. So the positioning of the center of mass, center pressure, rocketry is critical to its stability. And the center of mass should be towards the rocket's nose, and the center of pressure should be towards the rocket's tail to the fly straight. Okay, so this is the reason, because the rocket is basically vertical takeoff. So vertical takeoff thing, which the pitch moment is the top side, and the center of gravity is must be fixed in the center of the rocketry, because the both mass at the above and the downside of mass must be equally from the everywhere. Okay, that's why center of pressure and the control system is the downside, because that creates the drag and which provide the direction to the rocketry. So we can easily find, how can we find at home the center of gravity, center gravity like a CG of the rocket easily at home. Okay, so we just need to bind a thread at the center of the rocketry, and we have to move our circular path. So if we have experience or seen our rocket is travel in a straight path, that means we have bind our thread the right position, and that the position is the center of gravity of the rocket. So that this is the easy way we can find the center of gravity. But in another way, there is a many software, many design tool, many simulation tool, which we can take the information while designing, and we can keep our center of gravity there also. So basically, this is for the beginners. How can we find the center of gravity easily? For the scale rockets, rocketry we can use to find the center of gravity. We need to provide uh, uh, is very strictly, because that's allowed to travel in a straight path. Okay, if we cannot do it, once we ignite our rocketry, it will fly either there, here, and it will turn back to the ground. I don't know where it will go. Okay, so it must, we have to give the exact point, centrical point of the center. We have to know our draw a like a rocketry direction also while doing this stuff. So the basic material for making the rocketry is PVC material for the body, and for the nozzle also we can use the PVC material, because it resists a very high temperature, equal to more than 1800 to 25 degrees of Celsius. Okay, and we can also use the steel material, because the steel also can resist 1400 degrees Celsius. But if we will feel the some grain, so in solid rocketry, if we will feel, I'll tell you this about. Okay, I'll tell you in next step what I'm trying to say. For the making rocket structure, we can use the thin PVC pipes, so we can make it easily. So first, fuel test, how we can understand our fuel is working perfectively. So when 40%, I have already told you, 40% of like your fuel, which is in soft charcoal powder or sugar powder, okay, in the form of solid, in the form of powder, anything. So, and 57 or 56% of your oxidizer, which is nitrates, any nitrates, potassium nitrate, any nitrate, which is mixed together with ferric oxide and sulfur with limited amount. So after you can see, and there are two methods to making rocket fuel also. One is via melting method, and another is the powder form. Okay, so the melting, when we are try to make inside our kitchen, is very highly dangerous. So I'm suggesting you can make through it with the powder form, because the powder form is the easy way. We just need to do inside our mixer or some blender, so we can make through it. Okay, if we are going to making through the flame of the gas, that will be very dangerous. If you have the induction, then that will be safe. Use perfect goggles, uh, safety gloves also. Then you can make the melting mechanism of fuel. Like once you are just putting inside your pan, like potassium nitrate or sugar powder, it will automatically melt down, and it will mix together. So we can mold fuel in some specific shape also. Okay, so making of fuel test, I'm just showing you with some videos also. So I have some old video, I have found some old video in my laptop, so I'm just showing you how we can know that our fuel is working perfectly. Okay, so it is looking like red, because one of my friend which mixed with a ferric oxide. Okay, the ferric oxide, the color of rust is red. Okay, and another thing, inside the 3% of uh, sulfur, 40% of sugar powder. Sorry, 57% of sorry, 40% of sugar powder, and another 57% is your oxidizer. So how it works, we can see here. Once we are trying to ignite, let's see. So you can see the flaming speed, how danger it is. So now it's like a gunpowder. Okay, so be safe. Don't try to make it at home. So this is not my home. It is nearby my university. That was lab in 2019. We are just trying to making our propulsion lab. And there is another mechanism. Bomb calorimeter is another thing. We just know our fuel. The scientists are understand through that. There is a bomb. Okay, small ball above the area there is a some amount of water. So after the burning we understand the transfer of temperature from the bomb to the water. So on those way we can understand and we will get the some parameters of the fuel. But the easy way for the small scale of rocketry we can no, we just try to burn out and we can see the if it is slow burning that means it cannot fly the rocket from the ground. It will burn rapidly. That means it will works very perfectly. Okay. So
Sir, can you
in
play it
form
again
of
from the beginning?
I'll show you. Don't worry, I'll show you. I
Okay,
have
sir.
another video for you all. I'll show you. So basically, this is the different types of uh, solid fuel design. You can mold your fuel while you are making inside your kitchen. So there's a looking like some looking like softies. Okay, if you have seen the some muds in the form of semi-solid, so we can mold in any shape. So while we are making our solid fuel inside the kitchen, so it is very dangerous for because it is a highly explosive. So we just need to take many precautions. I will show you next time. So that I am just going to explain these all the shapes. The first one shape is the tubular shape. So the tubular shape basically at the initial time. So basically the thrust time graph. Okay, and the above the line that is the progressive. That means the thrust is increasing and with the time. So the in the tabular form, that means this is the place. If you can see my cursor, this is the place is empty place. There is a no any fuel. Okay. So once the ignition is started, so the space you can see the inside the ring. That is space. I have already told you before. We need space, maximum space, which produces maximum amount of combustion, which provide the maximum amount of flame. So the if we have minimum space, that means which produce the minimum number of flame, which produce the minimum number of thrust. Okay. Hello, I'm unable to listen now. Can you put your question in your chat box? So I'm trying to reply you. Actually, your voice is breaking up. So can you write in your chat box? Okay. Yeah. So I'm trying to give you answer. So actually, so basically, first tubular shape at the initial time, which provides a thrust, but according to the number of time, increasing number of time, it increases the thrust also. So I have already told you in the solid fuel rocketry, we cannot burn it in control. There is a no control system. So the after all, scientists find out we can burn through the some shape of the solid. So the in this shape we can burn the fuel in the form of control system. Like we just in at the initial time we need maximum number of thrust. Okay, so we put their different shape at the some stage at the some altitude we need some number of thrust, low number of thrust, high number of thrust. So we just make the accordingly the grain shape. So the before the making of fuel, we need to decide at what altitude, at what number of thrust we need. Okay, so the accordingly we made multiple types of and multiple designs of your grain inside the rocketry, because at the different altitude, at the different stages, there is a different shape of the grain. First one is the tubular grain, that in from the zero it increase the rapidity thrust, then and the sometime after 2 to 3 seconds it will the thrust will increase very slowly, so that is progressive. Okay, another form is rod and tubes. So the rod and tubes in this method, we need thrust as some specific amount but continuous. Okay, so we are using rod and tubes shape of the grain. So once is ignited and produce some amount of thrust, and then continuously the thrust is remains same for the required time. Okay, and the another in the rod and tube shape, we can see there in the center there is also some amount of fuel, and the outer area there is also some amount of fuel. Okay, but at the initially, if we burn this area, then we will see the some amount of space is there. With time, the burning is the continuous. Okay, and the burning rate is from the center to the outer area. We cannot burn from the outer to the center area. Okay, because this grain is also helps to resist the temperature to the outer body, because it's also working like an insulator. Okay, for the outer body. So the burning is starting from the center point, and it goes across from the, like you can say from burning through the circular in internal circular path of the rocketry grain. Okay, then after the double anchor shape, ones which provide the maximum number of thrust, and the width according to time, which reduce the value of thrust. So this is in this shape. If we need initially at the initially time, we just need a maximum number of thrust for the takeoff. So we have used double anchor shape of the grain. Okay, then after star shape is the most popular shape nowadays. Many of the space companies are the using star shape, because they in the star shape there is a maximum space. Okay, so the maximum space allow maximum amount of thrust. Okay, so that's why they are using a star shape, because the star shape produce very high amount of thrust with continuous time. That's why ISRO and most of the space company which using at the first stage of rocket of solid rocketry in the first stage, so they are using Starship. Okay, because at the first stage we need maximum amount of thrust for the takeoff. Once the takeoff is started, then we just need the amount of velocity. Okay, we just need the amount of velocity. So the it is simply we can understand from the your cycle. If you will try to start your cycle, the first pedal is very hard. Then after it will slower. But at the time you can see that your speed is very high and your pedal is very very light. You haven't apply a maximum amount of force, but at the initially you have to give maximum amount of force. So that's why I'm telling you at the initial time we just need maximum amount of thrust. So that's why they are using Starship. Okay, because they are the surface is there's a maximum surface for the burning. So the maximum surface which produces maximum amount of thrust. There is a multi-fin also at the first stage. For the 2 to 3 second or 5 second, it produce high amount of thrust. After all, it's coming down and produce some limited amount of thrust for the limited of time. Okay, and there's the two-step thrust is also, like I have already told you, for the 5 second I just need some amount of thrust, and after the 5 second, for the 10 second we just need some small amount of thrust. Okay, then after again I have we need some maximum amount of thrust, so we are using dual composition shape. These shape are using in hybrid rocketry. Okay, so how we they are making, so they are making like this. I'm just showing you, this is the way. So this is the molding function they are using inside the rocketry. So in rocket grain geometry, we can see first we have to design in our designing tool. Then we have to analyze how much thrust, what is the weight of our payload, what are the overall mass of our rocketry, how much the at what unit, what amount of newton of thrust we need to take off, so that accordingly we make the design. So you can see here the star design. If okay, if you wish to make the small size of rocketry, you can just give the ring shape. No need to give make star shape another shape, because this is the shape depends on the purpose. So the in different type of missile, short range, long range. So there is a different type of missile. They are also using the different shape of the grain. Okay. So how can we make? You can see above the stove there is a oxidizer, there is a fuel. So they are, after the burning, they are mixing together, and how it is looking semi solid. So with this the help, we can easily mold in any shape. Okay, we just need to make a metal mold system. So if we have mold die, if we have some die, so inside the die we can easily mold. Okay, so first thing I'm telling you, please take it seriously. Don't melt the fuel and oxidizer above the gas stove. Okay, because it is highly flammable and a highly explosive material. It takes it burnt up to 25 degrees Celsius, and that can easily burn our skin to the bones also. Okay, so please take it seriously. Without gloves, without safety goggles or helmet, don't use it in our home, because while we are trying to melting now, so a small amount of pieces are dropped from either here and there. So the after some days, it gets some amount of flame or some amount of heat, so it will be blast, it will be burned, it will provide the harm to our family member also. So please don't use it inside our home. So how can we make? They have made. He just made a die through the paper. Okay, so, ring shape of paper, and just put inside the mold material, so that he can easily mold in this way. So this is the easy way. But once again I'm telling you, use induction. So induction is the best way for the molding. Okay, so after that, you can see how the solid motors are look like. I have make in our college life. This is the small piece of rocketry, and how it is look like. So for the competition, so the precautions I'm just telling you. Proper storage. Okay, the room and the lab is from away from the peoples, away from the crowd. It must be away from the crowd, away from the peoples, away from the children also. Protective clothing equipment. Don't you, while the making this all this stuff, don't wear the plastic material. Don't wear the plastic material like silicon, like anything. Okay, when you are doing this all the thing, use cotton cloth. Okay, and the equipment we need to use in the material of wood, any or rubber. Okay, testing and quality control, we just need a person there who having like water and some types of thing like which can we can easily control the a small piece of fire. Okay, we don't use the big thing like fire execution also, because they are also harmful while we are dosing inside it, because the small amount of fuel it burns for just a second, so we haven't time to do this all this stuff. So that's why I'm telling you, you use protective glass and clothing and gloves also, and the emergency response planning before this all the thing. Make the emergency planning, so what happened if this thing is happening, so how we can fight against this. Okay, so before this doing stuff, do it with all the plannings. So I'm just showing you a video for the hybrid rocketry. At my college time we have made and we have tested throughout it. Okay, so just watch it. Where's that? I have already uploaded in my LinkedIn also. So when you are want to see, you can just see in my profile. Where is that? This one. Okay. So basically, there's a mild steel and HSS high speed steel material we have used for doing the test for the supersonic flow, and we have used the CD nozzle. Okay, and we have experienced the shock wave and the. So in this stage, we can see there is a V-shaped flame coming out through the rocket. So that produces the shock wave while we are using the serial nozzle. So same phenomena which you can see. Okay, but once again, I'm telling you, don't try to make and launch nearby your society, nearby your city. Make it and use it some specific area from your university, from the outskirts with the permission. Okay, because it is very dangerous for our society and our us also. Okay, and if you have any question for me, just ask. I'm trying to give you every answer from the everyone, for the everyone. Okay.
Sir, I am a member of Team Astrophile. We are
Okay.
Astronomy and Rocketry Club at Government College of Engineering and Research, Ausari. So we actually make model rockets. We have recently started, and we are experimenting with the KNSU fuel. So
Okay.
it's just that you must have heard about open rocket, right?
Okay.
So for the simulations, we actually used that, but then discovered our manufactured motors don't resemble with actually industry-made motors. So that isn't a reliable source. Like mass is different, specific impulse is different, and all that. So we came up with a solution for simulations with like design in SolidWorks, analysis of rocket body and all parts in ANSYS, like aerodynamics, center of pressure, center of gravity, and all, and then simulations on Simulink. But
Okay.
is there any other like short method like for industry specific motors? So that's just open rocket. Is there any other way for our manufactured motors?
Okay, okay. No, no. I'm just telling you, if you're working on the competition, so I have already worked in the, there is a competition, CANSAT competition in Texas. Okay. So I have applied for that and we have visited via our university. So that if you're facing this issue, so you just see the, what's your throat area of nozzle. Okay. Because the throat area of nozzle, which passes the amount of masses through it, and which produces the thrust. Because if you have made some small number of your holes, like your dia of your holes is very small number, so that flows the small mass, and that produces a small number of thrust. So you just analyze the what is you have been made standard number, or what kind of thing, and what's the exact number, you just need to know. If you have know from the open rockets software, if you know what's the maximum mass of your rocketry, okay, like if I am 10 kg of my mass of my rockets, so we just need 2x of thrust for the flying. So, okay, 2x, that means we just need 20 kg of thrust. So for the 20 kg, before that we have to test in with the weighing machine. With the help of weighing machine, we have to ignite the vertical direction of our solid rocket motors. So after we can analyze that, what is the maximum number of thrust we are achieving actually. So in this way, we can understand our rocket will flying or not. Okay. So use weighing machine before installation. So and test in multiple times. So you can understand the you are gaining your right value or not. Okay.
Yes, sir. Thank you.
Okay.
Good evening, sir.
Good evening.
Sir, my doubt is like I had also earlier I had tested two motors, which
Okay.
were means solid motors only, and the first one I done as you said by using directly the powder. But
Okay.
when I tested the powder, the thrust, or we can say the efficiency also, was decreased. And when means the structure wasn't like it's very stable. But when I tried with the can say melted one, which I had done with the induction as I had, so this one was that only in background which I cut. So it gave more efficiency.
Okay.
So like this one would be better for if we are trying to make a rocket, no?
I'm just telling you. Can you tell me what's the material of your nozzle?
Sir, right now metal, steel.
You have used
That
as
was just a
an
test. That was
okay.
just a test.
And
First basic one.
what's the material of your motor casing?
Sir, I had two materials.
What
The
kind
f-
of?
the first one was like not very thick, but kind of thick, kind of thin type of metal, which was steel.
Did you
And
feel
then
while did you feel while ignition your nozzle is blast or not?
no, it didn't blast.
So what's the problem exactly? If your nozzle, if your like rocket motors is tightly bound and which is made by steel, and the inside that you have filled your grain is tightly, okay, it with some specific shape, because shape is very important. That
Yes,
allows to for the flaming. So if we are using the ring shape, but if you are using the powder fuel, so the maybe if you have not compressed the powder with the some specific force, that after before the ignition, that is the hodgepodge. Okay, that will be the hodgepodge. So in condition of hodgepodge, so it cannot burn the exactly that you are the expecting, because it have the small surface area inside that. So the small surface area just exhaust some amount of smoke only. Okay, you cannot feel like some amount of thrust. What's your
yes.
desired thrust? Okay, so
Like
just make the
when I tested with the
yeah.
powder version, like the
Okay,
thrust was like I wasn't getting a like the expected value of thrust out of it. So I afterwards
okay,
tested with the melted one. At that time, I got the
okay.
means expected one.
First thing is your material of your nozzle, material of your casting, those all the like a casing of your bomb where you are making it. Okay, we can call bomb the casing of your covering the motors. Okay, so the material is very important. So so that there's a different type of material that provide the different stability, that provide the different amount of force, because that can resist some amount of temperature. So we have to understand the what kind of material we are using, what is the throat size of our nozzle, because throat size allow to come up the smoke from the rocketry which produces the
Yes.
thrust. So we have to analyze the throat side, we have to analyze our nozzle size, we have to analyze our rocket like a cylindrical shape size. Okay, so we have to know, and what amount of fuel we just need to carry out the our mass. So we have to understand that. So if you are using the open rocket software, so basic thing you can understand there. So how what amount of thrust you just need, so you can calculate easily while you're testing through the weighing machine. Okay. Now
Yes,
you
sir.
think, yes, Raj.
Thank you, sir.
Yeah, most.
Hi, Syed. I just want to know, it is not possible in a learning stage that we create each and every part of the rocket, especially the engine and the chip, the control model, whatever it is. So
Uh,
for a testing rocket purpose, okay, in the beginning, can we purchase all the material from the market, like
yeah,
website,
yeah,
whatever the
yeah,
store is
yeah,
available?
yeah, yeah. I'm just telling you, if you want to make your rocket fuel very easily, so nowadays the chemical shops they are selling their chemicals in very I'm telling you very expensive. So if you want to buy like a potassium nitrates, because this the very important composition, very important chemical for needed for the making the rocketry fuel. So you can visit the agriculture chemical shop where you can buy easily only 50 to 100 rupees per kg. Okay, there is a very cheap you can get through it. You can buy from that. Okay, so throughout this all, you can use PVC material from the hardware shop. You can use if you want to make through the metals. So there is some shop. Turning shop is also there. They are using like if I'm telling you simple language, lathe shop. So you can mold there your nozzle. You can mold there your every body, every sections. But I'm not telling you that exactly the name of for us, and we cannot use in our university or in our home, because it's very dangerous for it, because some of time our nozzle throat area is very smaller. That situation, the rocketry like mm, motor will be in a blast. So the in this section, the blast that provides a very dangerous cause. Okay, so the I'm not suggesting for the metals. I'm just suggesting you use the piece of PVC, use a piece of cardboard for the making this thing, because nowadays you all guys are beginners. So in this stage, you just need to try it to for the with the cardboard and PVC material, because the if you will calculate some wrong your throat area, so it will the choke, and after the choking it will blast with very very high temperature and pressure. So you are unable to listen, your eyes will be comes in the danger. So the many thing is there. So the just try to be safe and try it all in the lab only. That
Aside, actually, I want to know that can we purchase a already built rocket engine? Actually, I'm
all
asking about.
Okay, actually can't say to perform this all stuff in our society, but it is only allowing university, some of university which having the course of aerospace or aeronautical. So there is another propulsion laboratory. So only those guys having the license for making this all stuff, and some of the clubs also. Okay, so for the individually, there is a no permission, there is a no any kind of permission for making this all this stuff in India. But in US, you can do there is some specific area they have built in. You can test your to design or the shape of the rocketry. But in India, we cannot do. But in villages, like if we are from UP, Bihar, so you can visit some villages area. So we can make there. We can try there in the agri land. We can try there some scale size of rocketry. Okay, so that will be not comes under the danger. That's I'm telling you. So if you want to try a making, so make it inside the university ground only, because this will be the safest place. There is a no another people, there is a no society, and nobody comes to ask you why are you doing this all this stuff.
Thank you.
Yeah. Uh, Anything else? Hello. Someone is research Aditya Nair. Yes, Aditya.
Yes, sir. I also want to ask that. So, is there any substitute to iron oxide in our
Iron
lifeline?
oxide. Yeah, ferric oxide you can buy from the chemical store.
No, is there any substitute to it?
Substitute. You can make metal powder inside. You can get from the turning shop. It is nothing. Just it is a powder like a metal powder.
No,
So
like
if
aluminium, or we can use aluminium for that.
why you want to make aluminum?
No,
Aluminum
means
having
it
very
has more performance. Like
performance. If you are talking about the performance without research, so without
I
research we
had
cannot
read about
analyze
it.
anything. Okay. So aluminum oxide is nowadays
No,
using for as in the place
yes,
of oxidizer. Okay, they are not
yes,
using only, because
not oxide.
only aluminum,
Yes,
only aluminum powder we can use. But if I'm talking about the efficiency, the ferric oxide have maximum number of efficiency, because the melting point is a very high. Aluminum, once you are try to burn your ignition system, then initially it will melt down and vaporized. Okay, because the melting point, the burning temperature of the solid rocket motor is above 25 degrees Celsius, 2500 degrees Celsius. Okay, so the I don't think the aluminum metal will working in it. You can replace with some another material also, but that's why I have told you ferric oxide is very cheaper nowadays. You can get from anywhere. So that's why the people are using ferric oxide. And some
okay,
of
sir.
in
Thank you, sir.
advanced rocketry, they are using aluminum oxide in the place of oxidizer.
Yes, thank you, sir.
Oh, welcome. Uh, for the So is there any other question from your side? Please ask me, because uh, our time is over. It's going 10 p.m. o'clock. Okay, so I having very less time.
I
So
suppose there
if you are
is.
any kind of question, you sir. Yeah,
I
yeah,
suppose
tell me.
there is no question from the audience. Okay.
Uh,
Audience, there is any question, or should we conclude the session?
yeah, you can proceed. You can conclude this session, because it's a 10 p.m.
Yeah.
and I having very less time right now.
Okay.
And
So,
if you guys, I'm just giving my email ID or number. If you are any queries regarding this all this stuff, you can ask me directly. Okay, because I'm telling you this all this stuff. Don't try to make inside your home. And again telling you. And if you have any query, before ask me.
sure, sure. I will share the details and the LinkedIn profile of you in the
Okay,
WhatsApp
okay,
group.
sure.
Okay. And thanks for giving this wonderful session. I was
Okay,
like it was really from the basic of rockets to the propulsion systems. Okay, so it was really great. Okay, I hope the audience enjoyed.
okay.
Okay, so like audience, can we have
Most welcome.
we can have
Okay.
a snapshot with the
So
instructor?
yeah, continue. Continue.
Yeah, I was saying that can we have a snapshot with you? Like turn on your
Yeah,
camera
sure.
size. Okay.
Yeah, my camera is
No, no,
okay.
about your head.
Guys, please turn on your camera so we will get the snapshot with all.
Yeah. The audience was like in between, the audience goes around 35, but now it's 11. Okay, so yeah, it's happened. Okay, so
Okay.
yeah, so okay, we have the most of the audience. So just smile, okay, and hope by this propulsion system one day we will be going to the Mars. Okay, so thank you everyone. Thank you, Syed, once again for this wonderful
Most
session.
welcome. Most
Okay,
welcome.
and
Okay.
yeah, thank
See
you.
you again. Okay. Bye bye. Good night.
Bye everyone.
Thank you, sir. Bye,
Thank
sir.
you. Thank you. Yeah, Harish, anything?